Awesome. Can you hear me? Perfect. So, good morning. Welcome to NAG 76. My first name is Cam, and I'm the Senior Manager of Network Engineering at Qualcomm. I've been in this field for the past almost 22 years. I started as a systems engineer, and over time moved to network engineering. And now my teams are responsible for core, WAN, LAN, wireless, automation, you name it, different pieces of Qualcomm network, leader in 5G. Very interesting topic today, demystifying IPv6 over MPLS. And just something to say, over the past 2 decades that I've been in this business, I know many people, some faces here, and I'm privy to many conversations, not on IPv6 and MPLS though, on hiring process, right? Trying to find the right talents, senior level network engineers or architects. With all the cool certifications today, expert level certifications, it's not hard to find great experts, right? Someone jump on a keyboard, put a bunch of commands, or maybe do the design. We have JNCIEs, we have CCIEs, great technical skills, awesome. But one of the challenges when I get invited to a job interview, either our company or somewhere else, or review resumes, there is a little piece, and that's this mindset of being able to think outside the box. And what that means is, not necessarily what every single candidate claims. It's very hard to find a candidate that he walks into an interview and says, no, I'm not an outside the box thinker. Everybody is. But today's session, this session is about V6 and MPLS. I get it. Absolutely, we're going to cover that. But at the same time, I want to turn this into a mental practice for all of us to just think outside the box for a second. And I will tell you, I will show you exactly why that is so important. Moving on to the next slide, we actually structured this session in a very, very easy way. We're going to cover basics of V6. We're also going to talk about fundamentals of MPLS. And then we're going to talk about migration strategies, some pretty cool stuff. And also we're going to cover one of the real-world scenarios. We're going to talk about a company, and we're going to show you how to decide how to roll out V6 in the network. But that outside-the-box thinking challenge, that is what I want to really, really focus on. If there is only one takeaway that I want everyone to have when you're leaving this room, is that outside-the-box thinking practice. And that's so cool and so important, and I will tell you exactly why. Before any politician started building walls or talking about walls, we built walls. Trust me, we as network engineers, any titles, network engineer, architect, technician, whoever, we built walls. The voice guy started from here, and he said, this is my voice network. I'm not responsible for the enterprise part. I don't care about your core routing. The enterprise guy here, he said, you know what, the wireless guys, I don't care about your network, your RF, your APs, your controllers, that's your space. Whatever's going on in that space, you guys got to take care of it. That's not my problem. The security guy actually followed the exact same mindset. You talk to data center people, you hear the same thing. Service provider person, when you talk to service providers, as long as I have PE to PE connectivity, I'm totally fine. I don't care about anybody else. And from my perspective, sitting here, well, as long as I can get to your PE, then from that point on, that's your problem. From a responsibility perspective, I get it. That's important, absolutely important. That's fine. I mean, it's obvious. You're not going to be able to do everything. That's common sense. But at the same time, if all these walls, all these compartments, silos, cells, whatever you want to call them, we sort of decided to ignore solutions that each one of these towers, each one of these cells, compartments, silos, they came up with. This session is about removing at least one of those walls, or trying to remove, to tear down one of those walls, and going to this service provider world, grabbing one of the solutions that's proven, it's been around for many, many years, speed them up. We know it's a 100% baked solution, and bring it over to the enterprise world, and try to solve one of our problems in the enterprise world. That's why I really like this session. That's one of my favorite, really, really favorite sessions. So this is actually one of the interesting slides. There are some very common themes, and I'm sure when we start talking about those, you will relate to these. It might sound funny, but it's not really that funny. But let's talk about them. Anyways, there is one, and we call a new CISO syndrome, or a new senior security manager syndrome. You work in a company, you are the new CISO, or you just hire a new CISO, or this is a new security guy. The very first thing, they look at the problems and see, wow, look, we have a lot of issues. There are a lot of opportunities. There are a lot of security concerns. But we need funding for that. I've got to get my hands on a bunch of money in order to be able to fix all those problems. The very first thing, just human mind, just myself, my human brain, we connect dots based on our habits, based on things that we're absolutely used to. That's one of the things. You see all those problems, you want funding, and you just got the job. There we go, we start scanning the network. You grab some vulnerability scanner, and trust me, you scan 50,000 hosts, and you can just get, trust me, you can just go ahead and grab a Ford F-150, just the back of the truck, and thousands and thousands of pages of vulnerabilities, and take it straight to your CFO's office, and have him sign the check for you. That it absolutely is possible. People do it and it works all the time. Actually, 95% of the time. There is that 5% that you can potentially take the entire network down, or maybe half of, I don't know, city of Los Angeles down by scanning, by just recklessly scanning a network like an industrial network. There are SCADA systems out there, there are PLC systems out there, and guess what? Another wall there. We decided to build that wall, in case you haven't noticed, between the network engineering world, maybe IT, if you will, and the industrial world. We do not speak any common language. It's extremely hard for people to just walk in and say, you know what, I want to secure your network, but I might actually take your network down. That's one of those use cases that you just cannot apply that common sense, the inside-the-box thinking approach to the problem. Moving on to IPv6. So I'm sure many people here, quick show of hands, how many of you here, you have IPv6, any kind of IPv6 in your network? Almost everyone. When we start talking about IPv6, the very first reaction, again, human brain, myself, my brain included, we think about two things. Very first things that come to mind. Either tunneling or dual stack, right? We do tunnels, we do dual stack. These are the very first two things. You go to a job interview, first question, our intention is to, the answer, tunneling or dual stack. Why? We tried it and it worked, trust me. I have many use cases in the past that the solution worked perfectly. This session is about maybe another solution, maybe there is a third way. Maybe there is another possibility to talk about this problem. Maybe there is another solution that is not as invasive as doing dual stack, or not as shaky as tunneling. This session, by the way, is a tutorial. It is not an expert level advanced session. It is a tutorial, and not just a technical tutorial, but also this outside the box thinking tutorial. So just to set the right expectations. At the end of this session, I'm really hoping that all of us will have at least one more tool in our toolbox. It's not going to be a magic, but we're going to show you that, look, you know tunneling, there are a lot of different ways. Also, you probably have done dual stack, but this is yet another way of doing this. And that might actually work in your case. So let's forget about the whole IP world for a second. I want to talk about travel. And traveling around the world. How many people have traveled to more than 40 countries? More than 30. Excellent, more than 20. That's not bad. I mean, yeah, I guess everybody's local. So one of the interesting things, one of the amazing things when you travel, I'm a very curious person. I keep asking questions about all sorts of things that are not necessarily related to a business. So this thing here is my passport, right? Something very cool about this passport is Many years ago, people came up with an idea, a set of standards for these passports. So when you travel to some foreign territory, all you have to do is you present your passport. You even don't have to speak the language, right? You just present your passport, and someone looks at the passport, and probably he's going to stamp it. And from that point on, you can just travel through this country when you get to the border, and then leave that country. Another stamp and out. That's a great progress, trust me. That's an international agreement. But again, world travelers, probably, you will know about driver's licenses. Driver's licenses, when we get to that area, it gets a little bit muddy. So some countries, Australia, one example, I can use my California driver's license, go to Australia and drive, and I can do the exact same thing. I can drive on my Australian license, New South Wales, to drive here in the States for a number of months. But there are countries that you can ask me, and I have no idea. You have to Google that. And when you Google it, someone says, no, it was a great experience. I was able to drive on my local license. Some other folks say, no, we actually got pulled over, and the guy had no idea actually what was written on this. So those cases, they do exist, and we do have those problems. I will link that to our problems in the networking world very soon. Let's go on an imaginary trip. We're going to some country. We're going to go to some foreign territory. Interesting thing about that country is they don't speak the language at all. They have no idea about your ID. They can't even read it. But anyways, you have to pass through. In order to pass through, you have to do something about it. And one of the ideas is to have a common language, right? I have my driver's license, but they're not going to be able to read my license. They actually won't honor that at all. They have no idea what it means. When I produce my ID, they can't read it. That's the header. When I talk to them, when I try to explain the situation, they're not going to understand me. That's the payload, right? So no idea whatsoever. We are looking for a common language. That common language might be numbers. Actually, some smart people came up with that idea that, look, numbers are sort of universal. So pretty much anywhere in the world that you travel, this is number 2, or 2 up something. I have heard jokes that there is like this 1% that you go somewhere and this is like 6. I get it, but generally speaking, there is a great majority in the world, I mean, huge number of people that agree this is number 5, and I mean 5 of something. So we can use that as some kind of universal language. Numbers, right? So it's possible to apply, actually, let me go back and finish my non-technical lecture here. So it's possible to just think about this for a second, that as I'm presenting my ID, I might be able to also present some number. I will show you exactly what it means. And we have the same problem in IP world, like I mentioned. We have layer 2 and we have layer 3 on our packets. A layer 3 might be an IPv4 header, might be an IPv6 header. And on the line network may or may not understand anything about it. You're trying to push a layer 3 header, which is an IPv4 or v6, when the underlying network looks at it and says, colon, what does that mean? I mean, colon what? Or even the structure of the header is absolutely nonsense to the underlying network. So we can probably, and I will show you exactly how, apply the same concept and use numbers, not just when you're traveling, but also in this world. It has a name. It's called MPLS. Exactly that is what MPLS is all about. MPLS, when you grab MPLS books, actually there are extremely awesome books out there. I'm offering one MPLS, not MPLS, but Network Engineering Intermediate book, and it has a lot of MPLS bells and whistles. But trust me, all the fluff aside, MPLS is exactly what we just talked about. You want to travel in some foreign territory. Instead of using your own original ID, you're going to be using some numbers. And that's it. How? Simple. This is my ID. I want to travel. I want to go somewhere, and I have no idea. This is the very first step. I see the first security guy. A number is stapled to my passport. I just walk through. I see the second security guy. Might be a different city. Might be a different checkpoint. They're going to look at the number. They're going to swap that number with something else that the next post told us guys. Next post, next post, and next post. By the time I get to the end of the boundaries, the last post, they just take that number off, and I just walk back into my original country, where they're able to read my passport and honor my identity. We're going to do the exact same thing in IP world, and I will show you what. So here is one real-world example. That's actually a packet. If you look at the layer 2 part of that, we have the Ethernet 2, that's a layer 2. You see the MAC addresses. Also down at the bottom, you see the IPv6. There is a source, there is a destination, and by just looking at the source, I can tell you it's a web server talking to a web client. But these things are all common sense. You already know about all that. We all know all those fields. But we also inserted, sort of wedged, 2 numbers to here. These 2 numbers, label 17 and label 25, these are the 2 stickers. These are the 2 numbers. These are the 2 cards. These are the 2 labels that I attach to my packets for that packet to make sense to the underlying network. We're going to cover that in actually great details. Just let's bear with me, and we will cover that. So for now, I guess we set the stage that we know we have a problem. We know there are some potential solutions, and we want to look at some of those solutions, one very specifically in this case, 6PE. I want to talk a little bit about V6. This is probably the slide that all of you have already seen. Many people hate, and I will tell you exactly why. That's about the falling sky. It's a falling sky, it's a joke. Many years ago, late 90s, I was much younger, and in my early days, my boss barged into my room, right? Early in the morning, and disaster. Something like the Y2K thing, but different theme. So what's going on? What's exactly this disaster? How many IPv4 addresses do you have right now? I don't know, plenty, probably. I can double check. Look, V4 exhaustion. We're running out of V4s. The world is running out of V4s. Very soon, people are going to stop using V4s, and we're going to be moving completely over to V6. That was the story, trust me. The story was just that harsh. Scared everyone. Jerry, my manager, dude actually retired 10 years ago. He resides in Florida, and the only thing that he doesn't care about is V6, or V4, or migration, what I'm dealing with. It's gone, it's long gone. He's enjoying his margarita on the beach. But here's the thing, the problem is real. But there are solutions out there that as engineers, I would like everyone to explore, and today we're going to be talking about one of those options. We know the number of IP addresses, we know about the fields and everything. V6 Internet is a reality. We have some 70,000 rats right there. And the protocols are pretty mature, I guess, to some extent. Most vendors, when you talk to them, they do support BGP. Cisco, Atlas Families, or Juniper, or Arista, everybody. I can't really think of a vendor that do not support V6 at all. They support BGP. ISIS was one of the very first ones. Due to TLVs and all the great extendability features, they got V6. And that was cool. OSPF fully supported. EOGRP, thanks to Cisco, does support V6. There were a little bit problems with XR, but now it's fully supported. Quality of service, we read the labels, we read the labels, we also read the quality of service fields and make decisions, stable. Multicast, auto RP, if you're using it, it's not supported anymore, but there is BSR, there's SSM, bunch of other things, and that's cool. I actually missed something there. RIP. RIP is supported too. It's called RIP-NG. When we talk about RIP, we get a lot of smiles. I mean, people joking, oh, you're still using RIP. There are networks out there. There are pretty big networks out there, and they do use RIP. You don't need anything else. You have a bunch of routers, like chain of routers, and they run RIP. And it's been there forever. It's stable. So RIP-NG is supported too. One of the very first questions when we start talking about V6, let's just get this out of the way, like right here. that why not v6 everywhere? I'm building a new building, it's a new site, it's a new data center, it's a new lab, it's a new place. Why not v6 from scratch? Let's just treat this as a greenfield and roll out v6 from the get-go. There are all challenges there. We will be covering all that today, but when you talk about production networks, availability is a big concern. We don't want to roll out features that we have not tested a lot. There are some security concerns too. And the security guy, when you talk to a CISO or your senior, whatever, security managers, they are not as comfortable as with IPv6 features as they are with IPv4, as they are with v6, as they are with v4. So there are some security areas to explore, but that application thing is a big one. There are applications out there with hard-coded v4 fields that are not easy to migrate to v6. That's one challenge, and I'm not even talking about IBM or whatever mainframes running COBOL applications. I'm talking about your probably AAA server. I'm talking about some corporate applications. So it's not as easy as I decide to go v6 and day one, and I can roll just out v6 everywhere. Also, we will cover that. The migration solutions are complicated, trust me. There are challenges, there are some hidden challenges that people, sooner or later, will find out, maybe it's not just as easy as just run a bunch of v4 and v6 IP addresses on interfaces. The first solution that many people rolled out, we did too. Actually, I cannot think of a single company that I work for or talk to, and they never tried dual stack. There is dual stack everywhere, right? People like dual stack. So you have your v4 router, with all the v4 IP addresses and everything, you run v6. At the same time, it's a very invasive change. Why? Because if you have 50 routers, for example, well, you have a set of features for IPv4. Now you're going to have the exact same set of features for v6. I have slides on this, and I will show you some of the challenges in that area. And it's not really a migration strategy. People who decided to do dual stack, that migration strategy, trust me, that migration travel is going to take years, and probably many of those travelers have not arrived yet. They're still traveling. It's just like I decide to emigrate to Canada, and you know what? The process is going to take 21 years. So that's not really a migration strategy. It's sort of accommodation at the same time, but many people do that, and we will talk about it. There's also tunneling. We've been doing tunneling for a while, all sorts of tunnels. People are comfortable with GRE, IPsec. Who doesn't have it? Everybody. We have multiple different versions of tunnels. Our experience, my personal experience, and I work with many vendors, compatibility and that's nice interoperability, making sure that vendor A can talk to vendor B. That might be your challenge in the future, but not on day one. On day one, your problem is going to be vendor A talking to vendor A. I had one vendor, 100% trusted vendor, 2 routers, and the technical support was not able to find out what was going on. So they had to do packet captures, go back to the product team, look at the packets, and back to you. Wow, look, there is actually, you guys are hitting a bug, and it's not really a bug. It's something that we just did not develop, maybe. We should get this on a roadmap. So there are those use cases with tunneling. It's not as easy as I decide to run this tunnel, and it just happens. A little bit about my employer in Qualcomm. Very interesting story. Qualcomm founded in '85. It's a leader in 5G, and we have a very large community of engineers. What they do is they design chipsets for cell phones, 4G, 5G, and we need to test v6. We need to make sure that your phone, your future phone, works with IPv6. So it's a super critical case. Any mistake, if people forget to do some testing, you might grab your phone, actually millions of phones out there, and something just doesn't work. That's a pretty big deal. We decided to use IPv6, and we actually tried different things. Even right now, we have a mix of pretty much everything. Not much on the corporate IT side. I can't really think of a single case. Someone, just a random employee, knocks on your door and says, you know what, today I decided to use v6. No, but we do have some production V6 use cases. And also, I was looking at LinkedIn the other day. Seems like there are over 1,500 jobs directly related to V6. So the demand is real. Really, people are asking for V6, and there are V6 use cases. Today, we want to cover one of those cases, and we want to apply a not so usual solution to that problem. Down to our business. This is an IPv4 header. Everybody's seen this, trust me. I have the layer 2, layer 3, and also layer 4 headers there. It's an ICMP packet. Simple. And I use OSPF or ISIS. Might be ISIS, whatever, level 2 or OSPF. As soon as you run your IGP, the entire routing domain is going to learn about those 2,000 routes. Pretty simple. And then IPv4 packet starts traversing through the network, one hop to another. Very simple process, and makes it the end of the network. This is what happens in our networks every day. But let's look at the IPv6 packets. Layer 2, layer 3, and layer 4 data. Pretty cool stuff, right? Now, I have 2 islands of V6. In our case, those 2 islands might be 2 manufacturing floors, 2 engineering labs, 2 QA places that people are testing IPv6, and they absolutely need V6. In this case, we do dual stack. I mean, common sense, right? You hire this engineer, and he jumps on the edge router. He configures IPv6 on that box and those 2 green boxes. And also, he goes to those 2 islands, and he configures a bunch of IPv6 addresses for our engineers too inside those boxes. And we're good to go. That's an IPv6 packet, and it's ready to start its travel. I jump on this guy, and right there, without even making it any further, it's going to say no route. I have no idea what to do with it, because obviously, you do not have any V6 in the core of your network. We're always looking for ideas. One way of doing this, I guess in a very obvious way, inside the box again, is tunneling. This is what most engineers, especially when we deal with isolated cases. I like this, like very small scale things. We apply tunneling. Why not? Let's do that. There we go. Here is a tunnel. Cross-vendor issues. You know what? One vendor, I was having issues. You might be a lucky one. Who knows? But as you increase the number of vendors, the number of platforms, the number of codes, you might run into issues. It's not as easy, but let's say everything's tested in a lab. You're happy. We're good to go. There is this scalability question too. But when we talk about this solution, tunneling, and great engineers, always they talk back and say, look, this is a smaller scale design. I have 2 sites, requirement is very simple, and I need like a patchy solution for now, quote unquote, and we're good to go. Awesome, that's a patch. It does work. I absolutely have no problem with that. But over time, this is your network, you start rolling out those tunnels, and V6 is not something that it stays just in one location. Over time, you're going to have more V6 customers. That was exactly our story. And you start rolling out more tunnels. Your network starts growing, maybe cooking, and eventually you're going to have this. Trust me, I like spaghetti. I absolutely love it. That's one of my favorite foods. There is a little problem with spaghetti. I will tell you what's so cool about this. I have some of the greatest automation engineers in the world. I'm very, very proud of them. They can automate everything, including tunnels, including all those needles, right? It's possible to optimize that. It's possible to automate it. So it's not really manual. You can definitely make that argument and say, I have 1,000 tunnels, full mesh, who cares? And it's fully automated, not a problem. We are monitoring it, we're rolling it out, no problems whatsoever. There is another problem with that design. And we kind of touched on that. Today, if you have one vendor, one platform, one code, and everything is stable, tomorrow you're going to have to upgrade one of your devices. You're not going to, your network is absolutely impossible that you can guarantee for unforeseeable future. You run single vendor, single platform and single code. You start upgrading your edge devices, and you start running into issues. You are fixing BGP, you're fixing BFD. You're fixing BFD for ISIS bug, and you're upgrading your code. Your tunnels, they start flapping. Well, not sure how your automation engineer can help you out, but probably the solution is, let's go to the lab and scrub the code, make sure the code is stable, and then go back to the environment and just upgrade everything. So we're going to go from version 2 to version 2.2 to make sure everything is stable. And that story is going to continue pretty much forever. You upgrade something, you break your tunnels, and you go back. So that's an interesting argument that I get all the time. That's a temporary solution. Guys, trust me, you all know that. I don't have to repeat this, but the most permanent solutions in the world, in our world, network engineering, are the temporary ones. Things that, I mean, you know what, just for today, let's just do this. I'm going to do this. One static route here, one static IP address here. Later we'll fix it. I'm going to go back to this. I'm going to fix it at some point. And eventually, you're going to have that pile of mess. We all deal with that. So the third one, that's actually a very interesting, very, very interesting arguments that I get all the time. Look, tunnels are temporary. I'm going to do tunnels between now and 6 months from now. And in 6 months, we're going to go to dual stack. So we're going to have time to decide what we're going to do dual stack. And I'm going to get rid of all these tunnels. I would love to believe you. I mean, there is no way. Absolutely right. Get it. So let's do it. Now, it's been 6 months. And now I want to go dual stack. IPv4 and v6 everywhere. You can definitely make this argument and say, yeah, we're not going to do everywhere as much as we need it. I'm actually going to handpick some of these routers, some of these part of a network, some of these parts of the network, for example, here. I'm going to upgrade these 5 or 6 routers, and we need v6 here. Well, that's not really that easy, but I will show you exactly why not. Now in the core, partially or wholly, you're going to have very small network, 50 routers, or 150 or 1,500 routers, running v4 and v6 features at the same time. Let's say everything is stable. You're not running into bugs and no security issues, and everything is working. But are you sure everything is supported and you don't have to make any changes? For example, if you're running multicast auto RP with v4, there is no auto RP in v6. So that's not really apples to apples. So you're going to have to come up with some other solutions. But let's say you called your vendor, and on the phone, the sales guy, he absolutely said, why not? And you believe him, which is great. Do it. We just got off a phone, everything is supported, and that's great. You watch The Walking Dead? That's welcome to the rest, actually the first day of rest of your life. Now, where we go? It's not really that bad. First question, you have to decide to what extent. Do you really want to roll this out? 10 routers, 15 routers, 1,500 routers, how are they going to interact? You know what? We're too busy. We're not going to make that decision. We're just going to, just blanket change. We're going to change every single router in the core. We're going to go dual stack everywhere in the core. Again, some features and codes. Do I have to scrub those features? Do I have to go back to the lab and make sure everything works? Probably. And v6 features, they are great. They are almost mature, but they are not big enough features. How many people out there you can find and they used v6 in the core, pretty much the same configuration, same design as your network? These are those cases that you have to explore. And the hardware, does it support it? I guess so. We'll see soon. And also, maintenance windows. We don't care about maintenance windows. We have maintenance windows. But when you deal with mission-critical networks, especially the ones with poor capacity planning, it's not that easy. Many years ago, people built this network, and they had 2 circuits, 8 circuits, whatever, for capacity planning, extra capacity. But over time, initially they decided not to exceed 50%. So 50%, as soon as they approached 48%, they added some more capacity to have enough redundancy. But many networks in the core today, they just do not have enough capacity to have maintenance windows like that. And I'm going to touch every single router. You are going to impact some customers. We had that case. New features, new bugs, might be even the hardware. Stability in a core is always a concern, especially with maintenance windows. We talked about the bugs, and also automation and monitoring. Things that you have for v4, all the automation and monitoring, they may or may not work for v6. That's one of the questions you have to ask. And also the learning curve. Our experience, 6 months. So talented, smart engineers with no v6 experience should be able to configure, to some extent design, and speak to IPv6 in 6 months. So that's sort of the watermark. If you told me I had someone on my network and the guy is able to pick this up in 3 months, well, it's great, but average is around 6 months. So there is a learning curve and cost associated with that. A little bit beyond the scope, routing and stability is a problem. I'm not sure how much ISI experience you have, but as you start talking about 2 different layer 3 networks, IPv4 and IPv6, there are multiple different topologies. You have to keep that in mind. Might not be as predictable as you expect. And also systems readiness. Trust me, we as network engineers, we are, just throwing a number out there, seems like we are close to 80% ready. If you wanted to upgrade your network to v6, your devices, your codes, 80% ready. When you talk to application people, database people, mainframe, all these sort of things, I'm not even talking about IoT, right? They are nowhere close to 80%. So these are our challenges in this space. But it's complicated, we get it, but show us the requirements. We want to see the requirements. Let's say we go together to the CIO, CTO's office, and we want to see the requirements. Of course, I want the best of both worlds. You told us about dual stack, you also told us about tunnels. We want to have v6 reachability, no doubt about it, end-to-end reachability. I don't want to run into that spaghetti thing, I absolutely hated it. And also, new features. You know what's coming? Stay out of our core. v6 is cool, that's super awesome, but don't touch the core. I don't want any of these new features in the core. That's one of the requirements, many networks, unfortunately still. So we want something proven, something that's been used for many years. And at the same time, you know what? We actually heard of something pretty cool. Seems like some people are able to steer the traffic around the network. I don't know what it's called, but you can make different decisions based on QoS marking, based on v4, v6. Just go to this hop, don't go to that hop. If you go to this hop and there's a failure there, take this path and then take the other path. That's pretty cool. Actually, let's say if we can do that, and also that one. You know what, Cam? We absolutely love your v6, but keep it in your enclaves. Keep it within your enclaves. I don't want any of that v6 anywhere on my network. And also, the learning curve, 6 months, dude, that's not going to work for us. So this is sort of our general high-level requirements. There's also a list of nice-to-have things. Make sure it's scalable. Thousands of routes in the future if needed. We can expand it pretty quickly. You need new sites, you can bring it up. And also, you know what? We heard of that VLAN and layer 2 extension. I know that now that you're touching the network, it's absolutely relevant. But at the same time, I want to make sure that when we're doing this, your solution can support this. So if I have part of my network here, same VLAN, in different country, different city, on the same VLAN, and we want to have connectivity. It's crazy. I absolutely hate that. But that's still many people's requirements. And also, very low convergence time. Many people heard of that 50 milliseconds thing. And that's cool. We actually want that. This is sort of a requirement that we get all the time. As we start talking about rolling out a major big feature, just like IPv6 in the network. And it's not really relevant, I get it, but So what tunneling really did for us, it added a little bit of something. That something is that tunnel part, that header, to your packet. So your packet was able to traverse through the network, just like the sticker, just like the card that you attach to your ID. This is an MPLS header. Super simple, trust me, that's one of the easiest things. It doesn't have anything, actually it has four sections total. The most important part of that is the label. And that's a number that you attach to your passport. That's it. That header, just like that. You insert that header between header layer 2 and header layer 3. Some people call it 2.5, layer 2.5. But anyways, that's exactly what it is. You have layer 2, you have your layer 3. Between the two, you have your MPLS headers. Here in this case, I actually have 2 headers. I have 2 labels attached to that, 2 numbers stapled to your passport. I will tell you exactly why. There's a top label, there's a bottom label. We will cover that very soon. So let's get started and talk about this network. Very interesting case. So my edge router, it's going to advertise this loopback address. Very simple, 1111, advertise into OSPF or ISIS. Very soon through OSPF, the entire routing domain is going to learn about it. So they all eventually going to have that. But what your routers do, the intermediate routers, all the routers you have, what they do is something pretty cool. They start calling names. They start looking at your prefixes, the router you advertised, and assign number to them. This is the exact same concept that we just talked about. Numbering, right? I received the route, someone put that route in OSPF, I heard about it, I'm going to start calling that 2008. Going forward, my neighbors, both sides, when you're talking to me, my left neighbor and my right neighbor, I have no idea about that. I don't want to hear anything about this. Just talk to me numbers. Tell me 2008. Whenever you tell me number 2008, I can easily tell you where you want to go, what it is. I know that. I get it 100%. So it starts talking to right neighbor, says my right neighbor, look, I'm going to use 2008 for 1111. It does the exact same thing for the left neighbor. And very soon, the entire network, they're going to go through that negotiation phase. And they are going to let the neighbors know how they want to call each one of these prefixes. That is basically the core of MPLS, labeling. Anybody in a core will make decisions. Here's a list of prefixes. This is what I want to call them. My neighbors, this is my assignments, just FYI. You're going to hear the same thing from your neighbors. After a little bit of time, everyone agrees on what they want to call what prefix, what number. From that point on, we're going to be using numbers and not prefixes. So going back to this scenario, now I'm going to use the MPLS label. And I have my IP packet. We push that label, so the very first router decides to just attach it. Again, going back to my ID, it staples that. Let me just attach that number. Now I have number 230 or 230. I just attach it to my packet or my passport or my ID. It's called the push operation. And then I send it over. My neighbor gets it, swaps the number with something that his neighbor told him, whatever he said, this guy here, and again another swap, 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 pop. Let me go back. This was not swap. This is pop. So this router here, the penultimate router here, this guy here, just popped the label, and he sent it over to this guy. And done. Easy. This solution actually worked. You can argue that why did we need MPLS in this case to begin with? But I will show you how we can actually add more stuff to this simple case. This path, the path that we just took, it's called LSP, and LSPs or label switch paths. These are one way. So you go from right to left to right. There has to be negotiation, and you have to hear from your neighbors how and what they want to call each one of these prefixes to form these LSPs. So Nobody cares about the payload. Nobody cares about the headers anymore. I am a v4 router. Your header is v6. I don't care because I'm not looking at it for the most part. And you can, that can be anything. You can have like a bucket of beans or nails or screws. As long as I can process, I can read the MPLS header, we're good, we're fine. The three operations we talked about, push, swap, and pop. It's a cool example here. So let's say actually let me go here. I start my journey here in Florida. This is where I push the packet in Florida. Let's say Orlando, MC Orlando. I push the header. Now this is my MPLS packet. I send it over to Georgia. Georgia does a swap. Up to Illinois, another swap. Kansas, swap. To Colorado, swap. Down to Arizona, swap. When you get to Arizona, you do a pop. In Phoenix, just take that sticker off and send it to router in LAX. That's the same story with my ID card. I enter this country, attach their number. Here, the first checkpoint, I do a swap. The second checkpoint, I do the swap. All the way, they keep swapping this. The very last hop, before I enter the US again, they check this number off, give me my passport, and I go to the first US immigration checkpoint. All right, show me your passport. Oh yeah, this one makes sense. Cool. This is exact same concept. So I think by this point, with some oversimplification, I guess we should be clear on this. I have more examples, but the most interesting part of the session is actually the scenario that we're going to cover. We're going to use all this. We're going to show you how to use all this in a real-world scenario. So all in all, just to summarize this, we have a bunch of routers in a core. When we do MPLS, they look at the prefixes advertised in the heavy routing tables. They assign labels that let their neighbors know, and from there you can use MPLS labels. Simple configuration, that's a Cisco configuration. Juniper is just as simple. ISXR is just as simple. Basic very, very basic configuration, unless you really want to tweak some features. There are a lot of bells and whistles out there. You can optimize your LVP or other protocols, but this is basically the heart of that. But something very cool about this, maybe question that I should have asked, how do we assign this, how do we distribute these labels? So when R3 decides, for example, this guy decides to use some label, there is a protocol, very simple one, it's called LDP. It uses LDP. Remember we talked about that negotiation with my left and right neighbor? That LDP is exactly what's used. We use LDP to talk to our neighbors and tell them about our decision as to the label assignment process. I can see 4 prefixes, and I assigned 4 labels to those. And I'm going to let my left and right neighbor know through LDP that what kind of labels we want to use. So that's my MPLS core. Traffic flow, let's say in this example, left to right. We used LDP. Everyone now, they agreed on the same set of labels that they want to use. My packet starts traveling from R1 to R6. Of course, push, 320, swap, 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 pop. That's a penultimate behavior. And it might have worked if I had IPv4. But there is a bit of problem here. Remember that last segment of a network? That's your core. That's exactly where you promise your CTO, you promise your CIO not to roll out v6. That's part of a core. I am not able to roll out any v6 between the 5 and 6. That's a part of a network that has to remain v4. And now you're exposing your v6 packet to the v4 part of a network. It's going to get dropped. Problem right there. The smart people, as usual, when they faced this issue that R5 and R6 had no idea what to do with that packet, they decided to use 2 labels. The top label is the one that we're using for transit. The example I told you, exactly the passport example, the sticker that every single security point they check. And also there's going to be a bottom label, and I'm going to preserve that when I get to the last step, when I get to the last segment. and that's where it's used. Let's look at this. The top label here, in this case, is 17. The bottom label is 25. That 17 label, right, that one is going to get swapped. As I go from Florida to Georgia, from Georgia to Illinois, that's the top label, it keeps changing, keeps getting swapped by routers, but the bottom label never changes. Let's look at the example again. Now I have two labels, pretty cool. I have a bottom label that I promise to keep intact. And also I have a top label. Swap, you notice that, right? 320, 601, but 1358, that piece, the bottom label, it just remains intact. We're not touching that. 10, 7, 8. 867. Still 1358 is the same. Now let's see if we fix the problem. We did the pop. Look at this. We did the pop. 867 went away, got popped out, and now I have one label left. 5 and 6, they don't have to know v6. They don't have to do any v6 operation. We're still relying on MPLS and they're routing the packet. Pretty simple. Basic logic, and it does work. So, just to recap this, the top label, we use LDP. Everybody in the network here, all these routers, they use LDP to tell their neighbors about their neighbor assignment. This was the top label, the easy part. And also the bottom label. Every PE, every edge device, they look at the IPv6 addresses, assign labels to their v6 addresses. But when you have these edge devices and they want to assign labels to their v6 addresses, how are they going to talk to each other? How are they going to tell the other edge, the other part of a network? Let's say I have one edge in Florida, the other edge in LA. How is this guy going to tell that one what sort of label it decided to assign as the bottom label, which is the label assigned to the v6 address? There has to be a way for this router, for this end of a network, to talk to the other end of the network. Again, that end of a network to this end of a network, PE to PE, edge to edge, that this is my IP assignments. BGP to the rescue. As usual, we use BGP. And we actually use BGP for two interesting purposes here. One is label negotiation between these two. So my two edge devices, they use BGP. He's going to tell him what sort of labels he wants to use. These are going to be used as bottom labels. And at the same time, these are the actual prefixes. So BGP in this case is being used as a dump truck. Really nothing more. So your BGP grabs all these prefixes and all the labels included. That's very cool. And it's going to hold them all the way to the other end of the network and go dump them here to on the other PE. Hey, PE, look, PE2. PE1 decided to assign these labels, and these are the prefixes. Cisco configuration, that's exactly how it's configured, and it's super simple. This part, see these two lines? That's all I need. Trust me, nothing else. I activate my address family for v6, and also I configure send label, meaning when you're sending updates out, BGP update messages out, make sure you send the labels with them. And I can show you how it works. Let's advertise that little network in our routing domain and see what happens. So it's on PE1. PE1 sees it. Now I have a new prefix. 2031::31/128. What I'm going to do is I'm going to assign label number 18 to it. But I have to have a means to talk to PE2 sitting on the other side of a network and let him know that I decided to use 18, and that's a prefix that I have reachability to. There we go. This is one of my favorite slides. That's a BGP update packet. Check this out. This part, you see your BGP path attributes. You have your origin, your AS path, your MET, your local pref, everything else configured there. Down at the bottom here, the NLRI part has something pretty cool, which is the actual label for that prefix. This is what PE1 will be sending to PE2. These are the BGP updates. These are the routes. These are the V6 routes that one end of a network is trying to share with the other end of the network. And that's basically the heart of this session. That's how it works. Going back to the same problem. Now, going through that one last time, let's look at the traffic flow again. Swap, swap, swap. As you see, the bottom label is not being changed at all. We're not touching it. 18, swap. Now the bottom label is still there. R5 understands MPLS, R6 MPLS. They have no idea about V6 routing. 6 does, but not on that interface. And then out. That was it. That was exactly it. That's exactly how it works. That was all I wanted to share as a new way of, not a brand new way, but just another way of looking at the problem. And I will show you company A, which is just a fictitious company, right? It doesn't exist. But let's talk about the case. Company A is a laptop manufacturer with 150 offices around the world. Out of 150 offices, 20 of the offices are engineering and QA offices. These are the offices people sit and they assemble laptops, hard drives, and everything else. And also 30 corporate offices. They do HR, ERP, all the kind of systems. And also 100 small sales offices. And just so you know, they also have a lot of IoT boxes. They might have Xbox, PS4, PLCs, 6-axis robots, and SCADA systems. Variety of different systems. And also talking a little bit about their network. They built that network several years ago. And they use BGP, of course. Over time, they added route reflectors. They have a multi-tier network, and they use POPs that they built between 2012 and 2014. And the last one is a very interesting one. You get that all the time. The leadership, they understand the importance of V6, but at the same time, they totally respect availability of that network. They don't want anyone to mess with that part of the network, so whatever solution you're going to roll out, make sure you won't really mess a lot with the network, or at least you're 100% sure that whatever you're rolling out is stable. This is the email you usually get multiple times a day. Hope not multiple times a day, but multiple times a week. We get that very often. That someone wants to roll out a new feature, we need V6, or we need some other features, and the timeline was yesterday. We need that. And for now, it's just one location, but we're going to have more of this in the future. So it's just a sample email that this company, for example, received from the customer. Let's look at their problem. It's just a breakdown of the situation. They have a lot of unknown machines and IoT boxes. That alone kind of rules out machine-to-machine tunneling. I have seen people, they do client to client tunneling, and that works. But in this case, it's a little bit more complicated than that. And also the deadline. They need it ASAP, so you don't have time to touch every single device and change every single feature, every single V4 feature of that, or majority of the V4 features of that, and turn them into the V6 version of those. It's a little bit challenging for that case. And also vendor support. They have a variety of different vendors. When you're talking about, when you see that, and you are considering things like tunneling, you have to be very careful. Stability. I don't want to touch the core of the network, and I keep repeating this a lot. And also, scope can grow. Whatever solution you're going to roll out, you have to make sure that we can add sites in the future. Right now, 3 sites, but in the future might be a lot more. The options. IPv6 only sites. So those, how about this, by the way? Let's go to those 3 sites, get rid of V4 and roll out V6 and done with it. That's not really a possibility. We talked about it multiple times today. Systems are big roadblockers in most of these cases. Client-to-client tunnels doesn't really work in this case. Why? Because we have a lot of IoT systems. They have a lot of things that are not necessarily as fancy as probably Windows or Linux machines. Site-to-site tunnels, that actually might work, but the problem with that is, remember we had this solution should be able to grow requirement, and that's not really the best fit in this case. Dual stack everywhere, that's an interesting one. With enough time and enough confidence in my features, bug straps, codes, security, and everything, probably that would be an option. But as we talked about it, as we covered, that's not necessarily the easiest solution. At least it's not outside the box. What else? This might be a job interview question. What else? We know, okay, tunnels, yeah, but how about those challenges? Dual stack, everybody knows about it, but what else? What are the other ways? How can we be creative in this case? 6PE, the solution that we actually talked about today, I think that's a great fit for customers like this, for scenarios like this. It's just another tool. Let's look at the 6PE case. Now this customer, they want to use MPLS in the core. They have 3 sites, which is great. You don't have to have too many sites, but that gives you the ability to increase the number of sites in the future. Also, it's been, touch the wood, a very stable feature. Many service providers, the largest operators in this country, they've been using MPLS for many years. I'm not saying every single bug, but majority of bugs that you could possibly run into, there are records of those bugs with the vendors fixed, or at least they have workarounds for those. It's a little bit safer than rolling out V6 features, all of them in the core on day one. That MPLS thing is a little bit more stable. And also, the learning curve. Now that you have a V6 free core, it's not as steep. The stakes in this case are not as high. You were talking about, in this particular case, company A, you're talking about 3 sites. Those 3 sites, you rolled out V6. You're running into issues with V6. Quite honestly, people don't know how to do things. Well, worst case scenario, let me tell you the worst case scenario. They're going to take a building down. They're going to take a site down. They're going to take a lab down. Well, that's not okay, but it's not impacting the entire core. So it's a pretty safe learning curve. At least you can try, and you can trust small group of engineers because you're just touching the edges of your network, not the core. Reduce the number of new features. MPLS by itself and the LDP, the protocol for distribution that you saw, very, very few features in the core you're actually rolling out. With V6 in the core, you have OSPF, you're going to have OSPF v3. You have ISIS, you're going to have ISIS carry your V6 updates, probably different topology, or maybe same topology, and every single feature, you name it, you have to have the V6 version of that. You do encryption, you do authentication, good luck with it. You have to configure all those, and you have to deal with a lot of things, including bugs. But quick expansion is a very interesting one. With tunnels, you have to create those tunnels. With dual stack, if your dual stack is not everywhere, you have to go to those parts of the core and expand your V6 to those parts of the core. Again, you are making massive changes just to add one more site to your existing design. The solution that we just covered, using MPLS labels to carry V6 packets, you don't have to do that. You don't have to go to the parts of the network and say, this part, now I'm going to be rolling out V6 features and hope it works because it worked right there. We have a new vendor here, but it works. This solution doesn't need it. Going forward, 100 more sites, 100 more locations. You're adding to the network, you're not touching your core. You were just talking about the edges of the network. Your core is going to remain intact and hopefully stable. Automation and monitoring, whatever you've been using, you can keep using it. And also, because many service providers, major vendors, major operators, they've been using MPLS for so many years, there are many, many tools out there that you can take advantage and monitor your network. Once again, compared to IPv6, there are many great tools out there for V6, but compared to MPLS monitoring, probably I would vote for MPLS monitoring features. And MPLS, we actually covered that. It's been part of many codes for many years. Chances are great that your existing code in the core does support MPLS, and you don't have to make changes. You don't have to reboot devices. You don't have to go through maintenance windows, which is a great plus for many companies. The next one is a very interesting one, the users community. When you look at ourselves, we're sitting here, the number of people with MPLS backbones, when you go internet and just look it up and you go to different forums, the number of people with MPLS networks is far greater than the number of people with IPv6 in the core, running v6 everywhere, including core of their network. So you can get help from a much larger community. We talked about the scalability. This is network. This is company A's network, just portion of that. This is an interesting part. Remember we talked about route reflectors? With route reflectors, company A doesn't have to have full mesh BGP like this. What they do is they just establish BGP sessions between these edges and also the route reflector. Same story. Exact same story. I'm taking advantage of my route reflectors, and I'm not creating that full mesh mess in this network. Very, very simple. You can even have a multi-layer route reflector design. You can have a tier 1 route reflectors and a tier 2 route reflectors, and it does work. Remember the BGP configuration I showed you? Your destination was the other PE. In this case, your destination is the route reflector. Simple as that. So, towards the end of the session, the key part of the session really was to understand this, that there are ways out there that you can use. We just need to forget about these walls that we built for a second and see if we can take advantage of those solutions, bring them to our world and apply. MPLS is not necessarily the very first thing that network engineers, especially on the enterprise side, they think about this. We are, I hear that every day, we are MPLS customers. And then when you ask the next question, what kind of MPLS? Then silence. I don't know. Well, layer 2, layer 3. Even there are services out there that we use and we have no idea. They run MPLS behind the scene. There are point-to-point services. Point-to-point is actually a good example. I have been on a conference call, salesperson here, service provider, engineer here on this side, and I was listening, and he asked the third question. Are you guys using MPLS anywhere in your network? And the salesperson said, no, it is point-to-point. It's not MPLS at all. Why? Because MPLS is expensive, considerably expensive, right? Then the technical person, the service provider side, jumped in and said, no, we actually use MPLS. This is just layer 2 point-to-point connection on the service provider side. So MPLS is, if not everywhere, it's a very, very common technology. On the service provider side, I get it, but still we can take advantage of it on the enterprise side. It gives you that, in addition to everything, just some bonus points, it gives you traffic engineering, so you can decide from the source, and it's not segment routing, it's not anything fancy, from the source how you want to route your packets and what you want to do in case of any failure. Let's say there's a failure here, less than 50 milliseconds. I want to route around the failure points and do something else. Or, you know what, very important traffic, my voice traffic this way, my IPv6 traffic the other way. It gives you this ability as well. And also fast reroute. We talked about the convergence thing. So overall, that's a great feature, and I believe it works for many organizations. And something that you saw in company A's case, and I would like to kind of highlight here is, if you have VRFs, or VRF, in the US we usually pronounce it VRF. In Europe people say VRF, and it's not VRF like turf. Anyways, so VRFs, or segmentation, route segmentation, 6PE can be developed as 6VPE, and 6VPE is the right solution for those cases. Very, very similar to this one. And you can have VRFs on both sides of the network. VRF to VRF conversation. You can later expand this to customer conversation. Customer A wants to have connectivity, V6 connectivity, and you can provide that. And that could be actually a very interesting session. We talked about a couple of amazing points that could be future sessions. One of them is the 6 VPE. The other one was that industrial systems and how to secure industrial networks and how to tear down wall between our world. I keep saying our world. It's not really the entire thing is our world. Anyways, network engineering world and industrial systems and IoT world. That could be another interesting session. So the key takeaway in this case, 6PE is just another tool. You knew tunneling, a lot of different ways to tunnel. You knew dual stack, and I'm sure many people here will try dual stack, but just keep in mind, just back in mind for the future, there is also a possibility to have very simple, light version, just a stripped down version of MPLS, roll out in your network that's been around for many years, tested by largest operators in the country, and on top of that, start rolling out V6. It's not a full migration to V6. You're not going to give you V6 in the future, but anytime it takes, let's say 10 years, 15 years, and I'm sure just looking around the room, I think by the time all of us retire, we're still going to have V4, some parts of V4. Yeah, I like the smiles. So yes, by the time we get to that point, this solution can work. I am not sure about tunneling as you change your codes, vendors, and platforms. And I don't personally want to deal with dual stack in the core, but this thing can get you through the next decade or so until we have V6 everywhere. And I think that's a great solution. We're done with this. I'll open these questions. Any questions? We have some 17 minutes left. Cool. Please.
This is Prabhu. So when we do tunneling on IPv6 over MPLS, the egress point, the label doesn't make any sense. Anyway, we are going to strip out the label and do a lookup on IPv6 again. So in that case, why the ingress have to push different labels? It can be a unique label 2 only, right?
Could you just repeat the last part?
So the ingress is pushing one label through BGP.
The ingress pushes the label on, yes.
Yes, and there is a transport label. So
correct.
There are 2 labels, right? So the transport label gets swapped on each and every point, and when it go to the PHP, the transport label is stripped off, and the bottom label goes to the egress, right?
That's true.
Now, anyway, the egress point has to just drop the label and do a lookup on IPv6, right?
Correct. And it does understand IPv6.
Right. So in that case, why the ingress has to use different labels as a bottom label? Just one unique label should be good enough, right?
If I understand the question correctly, because of that last segment, between your penultimate hop and the ultimate hop, that port is not V6. You do not have V6.
I understand that. What I'm asking is, on the egress, you receive with a label and an IPv6. What are you going to do with that label? Just drop it and do a lookup on IPv6, right?
Yes.
So
exactly.
in that case, for the entire router, for all the BGP prefix, one unique IPv6, the bottom label should be good enough, right?
No, because the way it works is, for every single prefix, you're going to have a different label, and it points to that prefix. And also, you might have VRFs, and it knows where to place that packet.
No, I'm not talking about the VRF, plain BGP. So all the BGP routes go to the final box.
Yeah.
Let's say with 100 different labels. All the 100 labels are just going to be dropped. And anyway, you're going to do a lookup on IPv6 packet. So instead of 100 different labels, you can just use label 2. Explicit label. That's good enough for the egress node to just drop the label 2 and do a lookup on IPv6.
I see what you're saying, that might work and may not work in some cases. I'm thinking of some load balancing cases. But
maybe for VPN it's different. For plain...
For VPN it's absolutely different.
Right.
You're right.
For a different simple use case of BGP, all the ingress router can just put label 2. That's good enough, right? You don't have multiple
That
labels.
that helps you get from the penultimate hop to the
Yes,
last one.
that's good enough, right?
I see your point.
Thank you. That's what I want.
I see your point, yeah.
Thank you.
Another interesting question, now that you ask that, along the same lines that some people ask is, part of a lecture, when I was talking about, I actually used the word almost the 95% of cases. We don't care about the headers, the actual layer 3 headers. Not necessarily the last segment, but also everywhere. There is that small, very small percentage that the routers, they do care about what is going on in addition to your labels. Cases like load balancing, they will just pick through, have a quick look, and see what's going on. But for the majority of cases, 95, whatever, 99% of cases, they only rely on labels, and they don't care about what headers you have. Yeah. Any other questions? Please.
Hello, Ola Kasali with Facebook. I guess I have a similar question because my understanding is you can eliminate the penultimate hop behavior.
Absolutely.
And when you advertise the explicit null by putting a label there. So wouldn't that be a trade-off as opposed to using 2 labels, like label stacking?
It is possible. It's absolutely possible, yes. You can turn that behavior off, and you can keep that label on, and that's very helpful if you're trying to do quality of service end-to-end.
Yes, so there's the option.
Absolutely possible, you're 100% right.
Okay.
Yeah. And the use case, the quality of service use case, is actually one of the big reasons. There is one little use case, super corner use case. You're not gonna do that, you're not gonna see that anywhere. But it's possible to use a routing protocol that is not link state in the core with that feature, but keeping that label and helping your routing protocol. I don't want to make this complicated, we can talk outside, but there is that 0.001% of cases that somebody wants to do something absolutely crazy, like running, I don't know, EOGRP for traffic engineering or with MPLS. It's not impossible. There is that 0.001% possibility, and you can keep that label and take advantage of it.
Have you seen any trade-offs or any use cases where there are some things to consider in terms of, I guess I'm trying to understand why, or if there are use cases where people tend to do that more as opposed to stacking the labels and using 2 labels. Is it memory constraints, things like that?
Question for you. Are you talking about ISIS versus OSPF or OSPF and ISIS versus IGRP?
I would say more of the IGP not mattering, just more of the trade-offs between stacking the labels versus removing the penultimate hop behavior.
There are, yeah. So I don't want to turn this into MPLS in a core session, but real quick answer. Let's forget about EOGRP for a second, right? Mm-hmm. That's that 0.001%. If somebody really, really challenges you, it's a job interview. Can I use EOGRP, MPLS, traffic engineering in a core? Yes, you can. It's not great, that's not something that people do, but it's not impossible. It's absolutely possible. A quick answer to that. But OSPF and ISIS, that's one of the great questions. That differences in the core, and sometimes it gets religious. People, we've been using this for 150 years, they're absolutely stable. But beyond all these conversations, there are some subtle differences. One example, EOGRP, ISIS updates, the new TLVs that we added to ISIS for ISIS TE updates compared to the LSAs that we added to OSPF, there is a big difference. The difference is with ISIS, you increase the number of updates. With OSPF, you pack and send out. So in that sense, OSPF can, one OSPF TE router can be a little bit more efficient. But keep in mind, OSPF updates now going to the ISIS side, in ISIS favor. You can tweak your ISIS timers for the router to be quiet for 18.2 hours. Absolutely quiet. OSPF, you have this marking. You have to keep refreshing your database. That's why ISIS networks tend to be tend to be more stable, a little bit more quiet. So there are those differences out there, absolutely. They're 100% right. And in this context, if ISIS, we have multi-topology and single topology. We can talk about different vendors. What that gives you a lot of ability. How to design your network. Do I have to do everything overnight, or I can do multi-topology and decide how I want to roll this out? I want to do V6, this part of a network, I'm going to do multi-topology, and then take my time and upgrade the network as needed. With OSPF, the story is a little bit different, because OSPF v3 is a whole different protocol. It has its own world and LSAs and everything. Much better, much more efficient, I like it, but that's a different protocol. If ISI is same protocol, you can have different topologies.
Okay.
Thanks for asking.
Hey, I'm Aaron with Exelon. I did have a question, sorry.
Sure, yeah.
You laid out a great case for using MPLS instead of using dual stack. Are there any arguments or any alternative, or I guess benefits to using the dual stack approach?
Quite honestly, yes, absolutely. And that's a great question. MPLS, you can make the argument and say the time that it takes with my NOC to be able to troubleshoot MPLS networks and my NOC people to understand MPLS inside out, since it's a service provider technology, given what's going on out there in the training market, it's harder. Most people here, when they start the network engineering track, and it's a real world problem, I'm dealing with it on a daily basis. People start this, either Cisco or Juniper, they learn V6. V6 is part of the curriculum. I mean, even the basic ones, right? The NOC people that we hire, they understand basics of V6. I didn't lie when I said 6 months, but it's not really 6 months because most people know basics of V6. That's not the case about MPLS. MPLS scares people. When you start talking about MPLS, okay, NOC people, how many people here you have MPLS experience? We hired people from service providers, and the gentleman that we hired, he never actually configured MPLS. They would run a bunch of commands and send it to the next tier, and then the next tier. So MPLS, from a training, a learning curve perspective, unfortunately, is in a little bit disadvantage. But still, given everything that we talked about, I am more comfortable personally with MPLS in the core. But again, it's your organization's preference. You definitely don't want to send everyone through training for MPLS just to say, guys, we're going to be connecting 3 sites. Most people know basics of V6 these days. Probably, I would have had a different conversation 5 years ago. V6 was not part of training, many organizations. But today, most people, even fresh kids out of college, when we hire them, they know basics of IPv6. That's not the case about MPLS. Yeah.
Thank you.
Sure, yeah. We see that all the time. Yeah. Any other questions? No? Cool. Thank you so much for your time, and thanks for joining us today.